Hello students, continuing with our problems on polynomials, we have our next question which says verify whether the following are zeros of the polynomial indicated against them. Okay, so let's take our first problem. Our first problem says p of x equal to 3x plus 1, and we need to find whether x equal to minus 1 upon 3 is a zero of this particular polynomial. What it means is when we substitute the value of x equal to minus 1 upon 3, this polynomial should become 0. If it becomes 0, then we say these are the zeros of the polynomial. Sometimes we even call them roots of the polynomial. So we need to do is we need to substitute x equal to minus 1 upon 3 into this particular polynomial and check whether this polynomial becomes equal to 0. If it does it become equal to 0, we can then conclude that x equal to minus 1 upon 3 is a zero of this particular polynomial. But if we do not get it equal to 0 and we get some other value, that means this is not a zero of this polynomial. So let us check this out. So we have p of x equal to 3x plus 1. So in place of x, I'll put now minus 1 upon 3. So that would be minus 1 upon 3 plus 1. So 3 and 3 cancels over here. We are left with minus 1 plus 1, which is equal to 0. That means this polynomial becomes 0 when we substitute x equal to minus 1 upon 3. You can say therefore x equal to minus 1 upon 3 is a zero of the above polynomial. Okay, let's take another question. Our next question says p of x equal to 5x minus 4, and we need to check whether x equal to 4 upon 5 is a zero of this polynomial. So we just substitute in place of x 4 upon 5. So p of 4 upon 5 equal to 5 into 4 upon 5 minus 4. 5 and 5 cancels, we are left with 4 minus 4, which is equal to 0. We can conclude therefore x equal to 4 upon 5 is a zero of p of x, you can say, okay, of the polynomial. Let's go to the next question. Our next problem says p of x is equal to x square minus 1. So this is the polynomial, and we are asked to find out for two values of x which one is 0, whether both are 0, none of them are 0, or one of them is a 0. So we will have to input two values of x to check whether they are zeros of polynomial or not. So we will take x equal to 1 first. Okay, so for x equal to 1, we will take p of 1 equal to, instead of x square we will have 1 whole square minus 1. 1 whole square is 1, 1 minus 1 is 0. Okay, so x equal to 1 is a 0 of the polynomial x square minus 1. Let's check x equal to minus 1. So p of minus 1 equal to minus 1 whole square minus 1. Minus 1 whole square becomes 1. 1 minus 1 is 0. So we can conclude therefore x equal to 1 and you can say x equal to minus 1 are zeros of the polynomial. Okay, or p of x equal to x square minus 1. Okay, let's go to the next problem. Problem says p of x equal to x plus 1 into x minus 2. Okay, we need to check at x equal to minus 1 whether the polynomial becomes 0, and also at x equal to plus 2 if the polynomial becomes 0. So let's check with x equal to minus 1 first. So x equal to minus 1, p of minus 1 equal to, so in place of x I'll substitute it with minus 1 plus 1 minus 1 minus 2. Sorry. Minus 1 plus 1 becomes 0 into minus 1 minus 2 becomes minus 3. 0 into anything is 0. So that means x equal to minus 1 is a 0 of this polynomial. Let's check here x equal to 2. P of 2 equal to 2 plus 1, and this will become 2 minus 2. 2 plus 1 is 3, 2 minus 2 is 0, 3 into 0 is 0. So we can say therefore we can say that x equal to minus 1 and x equal to 2 are zeros of the polynomial, which is equal to x plus 1 into x minus 2. Let's solve another problem. So next problem say p of x equal to x square. We need to find whether at x equal to 0 this polynomial becomes 0. So we'll take p of 0 equal to 0 whole square, that is equal to 0. Therefore you can say x equal to 0 is a 0 of the polynomial. Next problem. Next problem is p of x equal to lx plus m, and we need to check whether at x equal to minus upon l, we need to check that x equal to minus m upon l, this polynomial becomes 0. So we'll, instead of x, we'll substitute it with minus n upon m upon l. So m upon l, so this is m upon l minus plus m. L and L cancels, we get minus m plus m, which is equal to 0. We can say therefore x equal to minus m upon L is a 0 of polynomial. So p of x is equal to 3x square minus 1, and we need to check whether at x equal to minus 1 upon root 3 and x equal to 2 upon root 3, if they are the zeros of the polynomial. Okay, we need to check these two values whether they are the zeros of the polynomial. For that we'll have to substitute these values in this polynomial. So let's begin with x equal to minus 1 upon root 3. So here instead of x we put minus 1 upon root 3. Let's see what we get. Minus 1 upon root 3, and instead of x square it would be minus 1 upon root 3 whole square minus 1. That comes to 3 minus and minus becomes plus, and root 3 into root 3 becomes 3. So this will be upon 1 upon 3 minus 1. 3 and 3 cancels, we get 1 minus 1, which is equal to 0. Okay. Next we'll check whether at x equal to 2 upon root 3 the polynomial becomes 0. So instead of x we substitute with 2 upon root 3. So we write the polynomial, that is 3, instead of x square we write 2 upon root 3 whole square minus 1. So that will be 3 into 2 whole square becomes 2 square becomes 4, and root 3 into root 3 gives us 3 minus 1. 3 and 3 cancels, we get 4 minus 1, which is equal to 3. So from here we can easily make out that x equal to minus 1 upon root 3 is a 0 of the polynomial, but x equal to 2 upon root 3 is not a polynomial. So we can say therefore x equal to minus 1 upon root 3 is a 0 of the polynomial, but x equal to 2 upon root 3 is not a 0 of the polynomial, because we didn't get it equal to 0. So obviously it means it is not a 0 of the polynomial. Next problem, p of x equal to 2x plus 1, and we need to check if x equal to half is a 0 of this polynomial. So in place of x we substituted by half. 2 half over here plus 1. 2 and 2 cancels, we left with 1 plus 1, which is equal to 2. We can say therefore x equal to half is not a 0 of the polynomial. Fine. So with that we finish with this set of problems where we get to verify whether particular values of x are zeros of the polynomial or not. Okay, so if you've liked this video, please hit the like button. Do not forget to share it with your friends. Please subscribe to the channel if you haven't, and click on the bell icon once you have subscribed to get notified whenever new video is posted. Thanks for watching. See you in the next video.